And welcome to Technology Tap. I'm Professor J-Rod. And this episode is Operating Systems Part 2. Let's get to it. All right. Welcome to Technology Tap. Thank you for joining us. For those of you who don't know me, my name is Professor J-Rod. That's J-R-O-D. And I am Professor of Cybersecurity. And I make this podcast to help students pass their A+, Network Plus, and Security Plus series of exams. Every now and then I dabble into Cloud Plus and CYSA Plus because that's the certifications that I have. But for now, mostly is A+, Network Plus, and Security Plus. I'm also on Instagram at Professor J-Rod. I'm also on TikTok. I'm becoming more active in TikTok at Professor J-Rod. And in TikTok, I do one 2-minute videos on questions or a topic. So join me there if you want. And welcome to Technology Tap. All right. On the last episode, we talked about operating systems and the different uses. So we're going to continue with that. This is part 2 of operating systems. So next we're going to use the user interface. The user interface is an operating system, serves as the primary means for users to interact with the system, access its features, and manage their computing tasks. And we're going to go over some of the different types of interfaces commonly found in operating systems. One is the command line interface, which is a text-based interface, which allows users to interact with the operating system by typing text commands into a command line shell. You don't want your users getting into the command line. Commands and parameters. Users enter commands followed by parameters and options to perform tasks such as file management, process control, and system configurations. Examples of these could be command shells like Bash, command prompt from Windows, and also PowerShell from Windows, which they provide CLI or command line interfaces. Graphic user interface or GUI. They have your graphical elements. GUI uses graphical elements such as windows, icons, menus, buttons, and dialog boxes to represent system functions and user actions. Users interact with the GUI by using a mouse, touchpad, or touchscreen to navigate through menus, manipulate objects, and perform tasks. Examples are Windows Explorer, Finder in Mac OS, Genome in Unix, Linux, and KDE, also in Unix and Linux environments. Next, we have touch-based interfaces. Touch-based interfaces are optimized for touchscreen devices like smartphones, tablets, and interactive kiosks. Users interact with touchscreen by tapping, swiping, pinching, and performing other gestures to control applications and navigate through content. Some examples of these are iOS Apple, Android from Google, and Windows 10 from Microsoft offer touch-based interfaces for most mobile devices and tablets. Next, voice user interface. VUI enables users to interact with the operating system and application using spoken words and natural language. You have virtual assistants like Siri for Apple, Google Assist for Google, Cortana for Microsoft. They use voice recognition technologies to respond to users' queries, perform tasks, and provide information. Hands-free interactions. UI offers this, making it convenient for users to control devices and access information while driving, cooking, or performing other activities. Next, we have natural language interface. A natural language interface allows users to interact with the operating system using natural language commands and conversational dialogue. Operating system employ natural language processing algorithms to interpret user input, understand content, and generate appropriate response. I guess an example of that will be chatbots, virtual assistants, and intelligent agents using natural language interface to facilitate users' interaction and automated tasks. So like when you're writing an email and then you're typing something like I'll be, and then it'll type by itself right back, right? So that's an example of that. Next, we have gesture-based interfaces. Gesture-based interfaces detect and interpret hand gestures, body movements, and facial expressions to control devices and interact with applications. Kinetic in Microsoft, Leap Motion, and other motion sensing technologies enable users to interact with games, multimedia content, and virtual environments through gestures and body movements. Accessibility features. I know Microsoft does a really good job with helping people that need accessibility. Operating system provide accessibility features and assistive technologies to accommodate users with disabilities and special needs. Screen readers, magnifiers, voice command, and other accessibility tools to help users with visual impairment, motor disablement, and cognitive challenge navigate the UI and access system features. Operating systems offer a variety of user interface options to accommodate different user preference, device form factors, and accessibility requirements. The choice of UI depends on factors such as user familiarity, task complexity, device capabilities, and accessibility consideration. Next, we're going to go to networking. Networking in operating systems refers to the ability of an operating system to manage network connections, facilitate communication between devices, and enable access to network resources. First one that we're going to talk about is network stack. Most modern operating systems implement the TCP/IP protocol suite, which includes protocol like TCP, Transmission Control Protocol, and IP, Internet Protocol. That's where you get TCP/IP from. These protocols govern data transmission, addressing, and routing on the internet. Network layering the TCP/IP stacks consist of multiple layers. This is part of the OSI model, guys, including the physical layer, data link layer, network layer, transport layer, and application layer. Each layer performs specific functions related to data transmission and network communications. Next, we have network configurations. Operating systems provide interfaces for configuring network settings such as IP address, subnet mask, default gateway, DNS servers, and proxy settings. Then we have network adapters, which are hardware components that enable computers to connect to networks. Operating systems detect and configure network adapters to establish network connections, like your wireless adapter or your NIC card. Right, those are examples of network adapters. Network protocols and services. TCP and UDP, Transmission Control Protocol, provides reliable connection-oriented communications between applications. Does a three-way handshake, right? SYN, acknowledge, and synchronization acknowledge. While User Diagram Protocol, or UDP, offers lightweight connection, communication suitable for real-time applications like YouTube and Netflix. Domain name systems resolves domain names to IP address, enabling users to access websites and network services using human-readable names instead of the IP address, right? Imagine if you had to know the IP address of your favorite websites. Would you go to the internet as much as you do now? Probably not. Next, Dynamic Host Configuration Protocol, or DHCP, which automatically assigns IP address and network configuration settings to computer and devices on a network. That's how you get your IP address. And there's a whole set of rules for DHCP. HTTP and HTTPS, Hypertext Transfer Protocol, which uses port what, guys? It's port 80. And its secure variant, HTTPS, which uses what port, guys? Uses port 443. Facilitate communication between web browsers and web servers, enabling access to websites and web-based applications. HTTP is not really around as much, as Google has punished websites that have HTTP by putting them lower on the search list. So they've kind of forced almost everybody to go to HTTPS. So I guess that's a good thing, right? Network services and utility. Ping, the ping utility test network connectivity by sending internet controlled message protocol echo request messages to a target host while waiting for replies. That's how you can tell that if your internet connection is working or if their website is up. It's not 100% accurate because there are companies like banks who refuse to accept ICMPs or ping requests. They'll just say no to them. Next, we have trace route, which traces the route and packets take from the local host to remote destination, providing information about the network hops and latency. This is good if you want to see how many hops it takes or how many routers it will take to go from your computer to like a website like NBC. So if you do trace RT space.nbc.com, you'll see how long it takes to get to your site. And it gives you a lot of information. If you look at it, at trace route, you see a lot of information. It's trace route for Apple and Linux. It's trace RT for Windows. Next, we have the netstack command, which displays network connections, routing tables, and network interface statistics on a local system. Then we have Wireshark, which is a network protocol analyzer that captures and analyzes network traffic in real time, helping diagnose network issues and security threats. And if you ever had a chance to mess with Wireshark, I would do it. It's actually pretty fun. It's a little complicated, but there's YouTube videos for that. So next, we have network security. We start with firewalls. Operating system may include a built-in firewall software to monitor and filter network traffic, blocking unauthorized access attempts and malicious connections. You have Windows Firewall for that. Next, we have secure communications protocols like SSL and TLS encrypt network traffic to protect data confidentiality and integrity during transmission. Then you have IDS and IPS software, which detects and prevents network-based attacks, intrusion attempts, and suspicious activity on the network. The difference between intrusion detection and intrusion prevention is intrusion detection lets you know, and intrusion prevention does something about it. Next, we have network file sharing. Operating system support network file sharing protocols like server message block, SMB, and network file systems, NFS, to enable file sharing and access to share resources on remote servers. Users can map network drives to local drive letters or mount network file systems to access remote files and directories as they were stored locally. You can do that through a server, or if you have like a network attached storage, a NAS drive, not the wrapper NAS, but NAS storage drive. It does that. Next, we have VPN. Operating systems include a VPN client software that allows users to establish secure encrypted connections to remote VPN servers over the internet. VPN use tunneling protocols like PPTP, L2TP, IPsec, and OpenVPN to encapsulate or wrap and encrypt network traffic, ensuring policy and confidentiality. Network capabilities are essential for modern operating systems, enabling the users to connect to the internet, access network resources, communicate with remote devices, and collaborate with others across distributed computing environments. Operating systems provide a wide range of networking features, protocols, and utilities to support diverse network configurations and communication requirements. Next, we have what type of operating systems that they have, right? So there's, we know the famous one. Desktop operating systems are designed to provide a user-friendly environment for personal computing tasks on the desktop and laptop computers. Let's take a look at some of the popular ones. First off, you're going to know this one, Windows, right? Version 11, Windows 11 is the latest version, right? Windows is known for this wide compatibility with hardware and software, extensive driver support, and a rich ecosystems of application and games. It offers a GUI with features like Start Menu, Taskbar, and Windows Explorer for file management. Windows integrates with Microsoft series of services like Office 365, OneDrive, and Cortana for productivity and cloud storage. Windows offers versions tailored for enterprise environments, such as like Windows 11 Pro, with features like BitLocker encryption, group policy management, and remote desktop. So always try to buy the Windows that is going to suit you. I remember I bought Windows Home for years because honestly, it was cheaper. And then when we started doing Zoom, kind of realized, yeah, this is not going to work because a lot of the stuff that I was asking my students to do, I couldn't even do it on my own computer. So from now on, it's Pro all the way. All right, next we have Mac OS. Mac OS is known for its sleek design, stability, and integration with Apple's ecosystems. It offers features like the dock, spotlight search, and mission control, and the Finder for file management. Mac OS integrates tightly with other Mac products and services such as iCloud, iMessage, FaceTime, continuity features like Handoff and Universal Clipboard. I've never used Handoff. Not really too familiar with that one. It also includes developer tools like Xcode, Apple's integrated development environment for software development across iOS, macOS, watchOS, and tvOS platforms. Wow, that's a lot. Apple rules the world, I think, or pretty soon. Next, we have everybody's favorite, Linux. Linux is available in various distributions or distros like Ubuntu, Fedora, Debian, CentOS, and Linux Mint. Linux is an open source and highly customizable with different desktop environments and package managers. Linux is a vibrant community of developers and users who contribute to its development, provide support, and create a wide range of software applications and tools. While Linux is popular for servers and cloud environment, many desktop users appreciate its stability, security, and flexibility for personal computing tasks. Next, we have Chrome. Chrome OS is a lightweight cloud-centric operating system developed by Google primarily for its Chromebooks and Chromebox devices. Chrome OS relies heavily on cloud services with applications and data stored and accessed primarily online through the Chrome browser and Google Workspace, or formerly G Suite apps. Chrome OS emphasizes security through sandboxing, automatic updates, verified boot, and built-in malware protection. Chrome OS is popular in education. It's extremely popular. Google's making a killing with Chromebooks in schools. And only because, one, it's cheap, and two, everything is saved in the cloud. You don't have to worry about the students deleting stuff. I mean, at least unless they delete it from the cloud. But still, it's a better environment for schools. I mean, they killed it when they did that. Honestly, they're making money hand over foot out of schools. And enterprise environments due to simplicity, low cost, and centralized management through Google Admin Console. And they have a good support. When I was a high school teacher, I was also the tech. They have pretty good tech support. Each desktop operating system has its strength, user interface, software ecosystems, and target user base. The choice of an operating system often depends on factors such as user preference, hardware compatibility, software requirements, and workflow needs. Next, we have server operating systems. Server operating system, a specialized operating system designed to manage server hardware, resources, and provide services to clients over a network. Let's take a look at some of the popular ones here. Of course, Windows Server, right? The latest is Windows 2022. Windows Server offers a range of features for file and print service, Active Directory domain services with server roles, web server roles, remote access, virtualization with Hyper-V, and cloud integration with Azure services. Windows Server comes in different editions, such as Standard, Data Center, and Essential, each tailored for specific workloads and licensing needs. We use Data Center at school. I teach a server class. It's actually one of my favorite classes because it's very hands-on. and we use Windows Server Data Center. Windows Server comes in different. Windows Server integrates with Microsoft ecosystem of productivity and management tools, including System Center, PowerShell, and Azure Active Directory. Next, we have Linux. Linux server operating systems are available in various distributions, such as Ubuntu Server, CentOS, Red Hat Enterprise, Debian, and Fedora Server. Linux is open source and offers flexibility, stability, and security for server deployment. It supports a wide range of server roles, including web servers like Apache, database servers like MySQL, and application servers like Tomcat. Containerization. Linux servers are commonly used for containerization workloads with technology like Docker and container orchestration platforms such as Red Hat OpenShift. Linux servers are often managed and configured via the command line using tools such as SSH, bash scripting, and package management such as apt and yum. Unix is next. Unix-based operating systems like FreeBSD, OpenBSD, and Solaris are used for specific server workloads and environmental enterprises. Scalability. Unix systems offer scalability, reliability, and advanced features for high-performance computing, large-scale database, and mission-critical applications. Unix systems are known for their robust security features, access control, and auditing capability, making them suitable for environments with stringent security requirements. Many legacy systems and enterprise applications still run on Unix-based platforms, leveraging their stability and compatibility with legacy software. Next, we have VMware ESXi, which I actually use in my server class, it's a bare metal hypervisor used for server virtualization, allowing multiple virtual machines to run on a single physical server. ESXi offers features for resource allocation, high availability, fault tolerance, and live migration, vMotion, of virtual machines. VMware and vSphere provides centralized management platform for deploying, monitoring, and managing virtualized environment with features like vCenter Server, vSphere Client, and vRealize Suite. VMware solutions integrate with cloud platform, storage systems, and network technology to provide a comprehensive virtualization infrastructure. And it's very good. I'm a big fan. I started using it last year, and I'm a big fan of it. We install a server on the box, and then using Hyper-V, we install another server, and then Windows 10 workstation or Windows 11 workstation, and then we connect them. We install Active Directory. We go on the command line. Students have a lot of fun. It's a very hands-on class. And they also have developer tools. Server operating system. Nope, that's a server operating systems play a crucial role in developing network services, hosting application, managing data storage, and ensuring the availability, scalability, and security of enterprise IT environments. The choice of server operating systems depend on factors such as performance requirements, application compatibility, licensing costs, and organization preference. And then we have mobile operating systems, which are specialized software platforms designed to power smartphones, tablets, wearables, and other mobile devices. Let's take a look at some. Android, developed by Google. Android is based on the Linux kernel and is open source, allowing device manufacturers and developers to customize and extend its features. Customization. Android offers extensive customization options for device manufacturers and users, allowing them to modify the user interface, install custom ROM, and customize system settings. Android devices such as the Google Play Store, Android devices access the Google Play Store, which offers a vast ecosystems of apps, games, and digital content. Android integrates with Google services such as Gmail, Google Maps, Google Assist, and Google Drive for a seamless user experience across devices. Next, we have iOS. and that was developed by Apple. iOS is a closed source operating system exclusive to Apple's mobile device, such as iPhones, iPads, and iPod Touch. iOS features a sleek, intuitive user interface with features like the App Store, Control Center, and Siri. iOS devices access the Apple App Store, which offers a high selection of quality apps, games, and media content. iOS integrates tightly with other Apple products and services such as iCloud, iMessage, FaceTime, Apple Pay for seamless experience across device. I'm actually a big Apple, not an Apple Mac guy, but a lot of the other stuff I like. The phone, the iWallet, Apple Pay. I'm a big fan of that. iPad OS, again, developed by Apple. iPad OS is a derivative of iOS, specifically optimized for the Apple iPad tablets, offering features tailored for large screens and productivity tasks. iPad OS introduced advanced multitasking features like split views, side over, and picture-in-picture mode, allowing users to run multiple apps simultaneously and enhance productivity. iPad OS offers native support for the Apple Pencil stylus, right? Enabling users to sketch, draw, and take handwritten notes with precision. That's really good. I bought one during COVID. Desktop class browsing. iPad OS provides a desktop class browsing experience with features like desktop websites in Safari, download manager, and improved text editing capabilities. Another one that I came across too is Harmony OS, developed by Huey. Harmony OS is designed as a unified operating system for a wide range of devices, including smartphones, tablets, smartwatches, smart TVs, and Internet of Things devices. Harmony OS adopts a distributed architecture, enabling seamless collaboration and communication between devices for a cohesive user experience. Harmony OS supports Android apps, allowing users to access a vast ecosystem of third-party applications while offering enhanced performance and security features. And also, Harmony enables cross-device collaboration features such as multi-screen, allowing users to seamlessly transfer tasks and content between devices. Mobile operating systems play a crucial role in powering the modern mobile commuting experience, offering users access to a wide range of apps, services, and digital content while providing seamless integration with cloud services and Internet of Things devices. The choice of mobile operating system depends on factors such as device preference, ecosystem integration, app availability, and user experience requirements. Yeah, I was a big fan of the Android. And then the Android kind of reminds me of a computer. After a while, it doesn't work as fast. I think it's missing scan disk or defrag on it, because after a while, like just to get a baseball highlight to open up, it takes forever. Anyway, it looks like we're gonna have to do a part 3 on operating systems, which is good, right? We're getting into the granular of how and the different choices of operating systems and how they work and how they function, which is something that we need need to understand for our CompTIA for the A+ exam. So this is a good topic. It's a little long. It's going to take me 3 episodes to cover the whole thing, but it's something that we need, something that is good for us to have. So don't forget, guys, I'm trying to build an audience on TikTok. I'm under Professor J-Rod, J-R-O-D. Click the like. If I get 1,000 likes, I can go live. And if I go live, I can do quick, question and answers on live. Or if you have an issue, maybe you have an issue with why are you having difficulty passing the CompTIA exam, and if we could have a one-on-one on TikTok, I'm more than happy to help you. I mean, this is what I do. This is what I'm here for, guys. Take advantage. This is how we, with education, this is how we get, have the ability to make more money and provide with our families by education. And this is the way, as they say in what is that show? Star Wars, right? This is the way. So look out for me, email me, get in touch with me. There's various ways, and we can build this community and continue to help each other out and become big players in CompTIA. So until next time, we'll see you on the next episode, which should arrive within about a couple of days. Right? I'm trying to be a little bit more cautious. I know things get busy. I get busy and sometimes I forget, and I apologize for that. But as you know, there's a lot of things that I'm doing, and hopefully a lot of great things happen in the future for I can play forward in this journey. A lot of people have helped me, and my job is to help you and help other people in this journey, just like people have helped me. So until next time. This has been a presentation of Little Cha Cha Productions. Art by Sarah, music by Joe Kim. You can reach me by email at professorjrod@gmail.com. You can also reach me on Instagram at professorjrod or on TikTok at professorjrod. That's JROD.